Hello, I'd like to talk to you today about modeling quadratic equations. And today we have a quadratic equation that we'd like to model, or we want to write the equation for this parabola. So it says a boy tosses a water balloon to a friend 10 feet away. The balloon will be tossed and caught at a height of 2 feet from the ground. The balloon's maximum height in the air is 6 feet, and we're going to write a quadratic equation that models the path the balloon takes. And we're going to graph the model. So let's begin with just some knowledge. So we have essentially two kids and they're 10 feet away from each other, but they're both tossing and catching the balloon at the same height, which is 2 feet. And we know that when the balloon is in the air the highest, the maximum height, it's 6 feet in the air. And so we're going to start with a graph of this model. So we're going to use an XY axis, and I'm going to start and stop the balloon with a height of 2 feet. So its initial height is 2 feet, and when somebody else catches it, it's also going to be at 2 feet. And we know that these friends are 10 feet away, and we know also that its maximum height is going to be 6 feet. And we know that since it takes the path of a parabola, and a parabola is symmetric on both sides, that halfway between 0 and 10, we're going to find 5. So we get that parabola looking like this, and we know that the vertex is going to be at 5, 6, or what we call the local maximum. Okay, we also know that the y-intercept is at 0, 2, and there's another point across the way that is 10, 2. There's a couple of forms that our parabola could take if we wanted to write an equation of it. We could write it in standard form, we could write it in vertex form, we could write it in factor form. But since we already know the vertex, I think writing it in vertex form would be really nice and kind of easy, actually. So here's the formula for vertex form. Y equals a times the quantity x minus h squared plus k. And we call that vertex form. Some books call it graphing form. And we know that the vertex is going to be 5, 6. So 5 is h and 6 is k. And all we've got to do is just plug it into that equation. Okay, so there we go. And what we need to do now is just solve for a. And remember, if this goes fast or you need to stop it to catch up while you're taking notes, that's fine too, no problem. So now we're going to solve for a. And actually, there's an infinite amount of parabolas that would have a vertex at 5, 6. Some go up, some go down, some are really thin, some are wider. And so if you think about all of the parabolas that could happen at that point, there's a ton of them. So A is the thing that controls the parabola that we have. There's only one parabola doing what we're doing right here, and we need to find that A value. We know that the A is going to be negative because this parabola goes down, and it's going to help decide how wide our parabola is. So we have to solve for it. So what's the trick to doing that? We're going to solve for A by just picking any point on the parabola, any point at all. I usually don't pick the vertex because the vertex won't tell me anything. So any other point on the parabola, and I always pick something easy. So look at your parabola, see if there's an easy point that you can use, and if there is, you're going to go ahead and plug it in. So the easiest point I see is 0, 2. I could have also used 10, 2, but I like 0 because 0 is friendly. So I'm going to go ahead and plug in 2 everywhere I see a y value and 0 everywhere I see an x value in order to solve for a. With a little simplification, moving the 6 to the other side and squaring, I end up solving for a, and a is negative 4 25ths, which is great news for me because I already knew that the parabola was going down. So there's my a value, and then there's the vertex of the parabola, and essentially that's the path that the balloon takes. Awesome. Thanks a lot.